Hello everyone, good morning. Today we are starting with our sessions related to our previous year questions of the NDA. So our first question related to our NDA previous year, and this one year previous year NEET question beta, that is the magnitude and direction of the current in the following circuit. Then your circuit diagram is given. Okay, in this circuit diagram we have to check their direction of the current and how much amount of the current, magnitude of current we have to find out. So see this one question here. There is a two batteries are given, there are two voltages are given, there three resistances are given. Then first we have to check then how their current will be flow in this circuit. So here this one will be 10-volt battery and another one is a 5-volt battery. Okay, two batteries are there. Then we have to check the terminal of these battery. If there is a same terminal like this one, we are attaching two battery like this one, positive negative, then positive negative, then their EMF voltage if we are writing their E1 and E2 like this one. Okay, so here total EMF of these battery we can write their E1 plus our E2 like this one. Okay, like this one we can check E1 plus E2. Okay, if two battery we are connecting like this one, negative positive and here positive negative, like this one we are attaching to battery terminal like this one, negative positive and positive negative respectively. Okay, here voltage if you are writing E1 and E2, then E we can write there which one is a more voltage, then we will subtract the less voltage from that more voltage. Okay, so if this one is a large, then we can write there E1 minus E2. First we have to check then how many voltages are given in our circuit. There is a 2 voltage, then we will check there how many terminals, how their terminals are connected in our circuit. If you are connecting order of these circuit like this one, positive negative, positive negative, positive negative, then total EMF in our circuit, total voltage in our circuit, we can write there E1 plus E2 plus E3 respectively till our nth. Okay, but if like this one way will be there, negative positive positive negative, otherwise opposite, positive negative positive negative, like this one will be given, then we can write there E1 minus E2. Okay, more voltage minus less voltage. So see here 10 voltage, then your 5 voltage, then current will be flow from between 10 voltage toward the 5 voltage. So like this one current direction will be there in the circuit diagram, more to less. Okay, so here 5 voltage, this one here 10 voltage, then total voltage how we can write there? We will write there total will be, check your terminal like this one or this one, like this one way. So total voltage in this question we can write there E equal to our 10 minus 5, E1 minus E2, then we can write there 10 minus 5, then it will be left there 5 voltage. Okay, current will be from positive to negative, but again here one more voltage, that's why we will check which one is a large value, then we will pass the current from high to low voltage. Okay, so here direction of the current in your options are given, direction as well as the magnitude. First we are checking the direction. So direction A to B, like this one current will be flowing the circuit like this one way. So here we can say here options are given B to A, B to A to B and A to B like this one. So see here A to B or B to A, your direction is like this one now. So right option should be your A to B like this one. So these two options may be right. Here A to B in both option. So direction in both option wrong. So we have to check these both option. Direction should be A to B. Now we will check the magnitude of the current. Current how we can find. Okay, so by using Ohm's law, then we know about this one, V is equal to our IR. Yes or no? This one no, by using Ohm's law we can write there V equal to IR. V equal to IR. So from here we have to find out current, what is the magnitude of the current in this circuit diagram, V by R. So V we can write there, V is our voltage in our circuit. There is a 2 voltage in our circuit, then we will find the total magnitude of both voltage. So here we can write there 5 volt, 10 minus 5, then it will become equal to our 5 volt. Divide by your resistance, then here 3 resistances are given, then we have to find their equivalent resistance in our circuit. Equivalent resistance 1 ohm, 7 ohm, 2 ohm. Then first we will check these all resistances are given in series or parallel. Okay, so here check there all resistances are given in series only. So equivalent resistance here in series we can write there R1 plus R2 plus R3 up to nth, like this one series will be going on. Okay, so as we are putting value of here, then here we can write there 2 plus your 1 ohm plus your 7. So here we can write there 9 ohm. Like this one we can write now. So equivalent resistance came ours 9 ohm. So here as we will put their value of equivalent resistance, so we are putting there 9. Okay, 5 volt divided by your 9 ohm. Clear? So as we will solve this one, then here which one answer will be there? Now we are solving, I should be there. Your option will be better out of these two only. If you will divide this one, that will be not give us 2.1. Yes, now because it will be 0.5 ampere should be there. Clear? I hope you understood better how we can find this one. This one your NEET previous year question. So your diagram is given. With help of the diagram, we have to check first how we can find the direction of the current. Current always will flow positive to negative terminal, but here we will see better another more voltage is there and their terminal is opposite to the previous one. Okay, that's why we will check there which one is having large voltage as compared to the another voltage. So we will draw our current from high voltage to the low voltage. So like this one, then our current direction will be like this one, then A to B will be there. So two option will be cancelled out in which direction is given B to A. So two left, then out of these two, then we will check their magnitude. Okay, which one will be right? Clear? So this one magnitude here, voltage given, resistance given, current we have to find out. So relation between them only we can find by using our Ohm's law, that is EV equal to IR. So here I we can write there V by R, then we will find their equivalent voltage, equivalent resistance as given our circuit. So by using this one, then put here, then our current will be came out, that is coming here 0.5 ampere. So C will be our right option of this question. Next, 10 resistors, each of the resistances are connected in series to a battery of EMF E. Okay, 10 resistors are given, each of the resistance are given R. 10 resistor given, each of this one. As we are connected in series, then EMF E we are connecting there. Okay, your part 1, in first one line that is given that R, each of resistance is R. So in series we can write there, in series we can write their equivalent resistance. R equivalent we can write there 10R, because in previous question done na, in series to equivalent resistance how we can find R equal to R1 plus R2 plus R3, like this one. So in series equivalent resistance we can write there 10R. Then these are attached with the EMF, battery of EMF E, and negligible internal resistances. We are not taking the internal resistance of the battery, we are including only the external resistances which we are connecting in our circuit externally. So then those are connected parallel to the same battery. Okay, parallel to the same battery. Initially our voltage is given equal to your E. So in next, then same resistances we are connected in our parallel, then current will be increased n times. Okay, as we are connecting the resistances in parallel, because in parallel as we are connect the resistance, then resistance will be less there. Okay, in parallel connection. If less resistance will be there, then current will be more. Okay, so here B we can write there E given in a question. Now in parallel, second way, in parallel given. In parallel, we can write their equivalent resistance. How we can write there? Equivalent resistance in parallel, we can write there 1 by R equal to your 1 by R1 plus 1 by R2 plus 1 by R3, like this one. So each resistance is your R value only up to our 10. Okay, up to our 10. So here we will solve this one, then here we will write there beta R equivalent we can find or not. 1 by R equivalent will become their R LCM. Each of value is R na, we are taking R only. So here we can write there, after taking LCM, then it will become equal to 10 by R. So this one is the 1 by R equivalent. We have to find out R equivalent. So R equivalent we can write from here, then R equivalent will become equal to R by 10 in parallel. Okay, now see here, in parallel also connected with the same battery. with the same battery connected means initially if battery voltage is E given, then after the connected in parallel, then its value of the battery is E only. So in that case also V equal to our E only. This one given, this given. Clear? Then here we have to find out current is increase n times. कि current कितना increase हो जाएगा, n times increase हो रहा है, खुद कह रहा है कि n times increase हो रहा है, उसी n की वैल्यू हमें find करनी है. Clear? So first we have to find out current in both cases, then we have to check there how much current will be increased in our parallel connection. So here we can write it beta initially. We have to find current by using your Ohm's law, then voltage and R is given, then I we can write there V by R. Yes? Okay. So in series current will be equal to, in series we can write there current equal to V by R. V equal to our E only and R equal to your 10R. R equivalent क्या given हमारा क्या आएगा? As we are connected in series, then it will be equal to 10R. So same your current will be in parallel connection if you want to find out. Then again we will apply there V by R. In parallel connection, in both cases voltage will remain same. So we can write there E only. Equivalent resistance in parallel connection we have done already. R by what? R by 10. Came now this one equivalent, as we will take opposite of this one, inverse of this one, then R equivalent will become equal to R by 10. So it will be equal to your R by 10. So here 10 will be upper side, 10 E divided by your R. Okay. So your current I will be equal to your E by R. This one your ampere. This also will become ampere because your SI unit will be this one. Okay. Only we have to find out how many times will be increased this one. Clear? So if we will find the ratio of this one, then we can solve it. Yes or no? So as we will take this one, then it will be coming beta in series, then it is coming your 1 by E by R. Okay. And this one I parallel will be equal to your, this one your E by R. Okay. So this one I parallel will be equal to your I series. We can write from here. We can write from here I series E by R equal to your 10 I in series. Okay. We have find out only how many times ना, कि कितना times आपका करंट इंक्रीज होएगा इन पैरेलल कनेक्शन. ये तो हमें पता है पैरेलल में ही ज्यादा होगा, क्योंकि सीरीज में क्या होता है, रेजिस्टेंस को हम कैसे ऐड करते हैं, R1 प्लस R2. तो सीरीज में रेजिस्टेंस ज्यादा होता है, करंट क्या होता है, कम होता है. बट पैरेलल कनेक्शन में रेजिस्टेंस कम होता है और करंट क्या बनेगा, अपना ज्यादा फ्लो करता है. ओके. सो यही हमें फाइंड करना है कि सीरीज के अंदर जो हमारा रेशियो आया वो क्या आया, I करंट इन सीरीज E by 10R. So हम फाइंड करेंगे E by R equal to 10 times of the current in the series. So as we are putting here E by R from this one, then we can write there I parallel current in parallel equal to 10 times, and E by R we can write there 10 times of the current in series. Okay. So here we can write there it will be 100 times of the करंट इन सीरीज. ओके. ये सेम 10 रेजिस्टेंस को अगर आप बैटरी EMF E के साथ अगर कनेक्ट कर रहे हो तो उसके अंदर जो करंट फ्लो करेगा, सेम अगर उन्हीं रेजिस्टेंस को अगर हम पैरेलल में कनेक्ट कर रहे हैं तो उसका क्या होगा, 100 टाइम्स क्या है, करंट ज्यादा फ्लो करेगा इन आवर पैरेलल कनेक्शन एज कंपेयर टू दी सीरीज. I hope you understood beta. So here will be right option I parallel equal to 100 times of the series in the current. So it will be right option will be our C only of this question. Okay. This also our previous year's question of the NEET. So next question we will discuss beta. If the current through the electrical machine running or direct current is a 15 ampere and machine runs for the 10 minutes, then charge that passes through the machine during this, options are given. This year NDS previous year question, last year questions only. Okay. So in that question your current is given in our question beta 15 ampere. Okay. So here we have to find a current. This 15 ampere is flowing in our circuit for a 10 minute. ओके. तो ये पूछ रहे हैं कि 10 मिनट के अंदर अगर हम 15 एम्पियर करंट अगर पास कर रहे हैं तो कितना फ्लो ऑफ चार्ज रहेगा, हमारे चार्ज कितने पास करेंगे. ओके. सो Q वी हैव टू फाइंड आउट. सो हाउ वी कैन फाइंड Q, देन एज गिवन इन आवर क्वेश्चन, क्वेश्चन के अंदर हमारा गिवन है I इक्वल टू आवर 15 एम्पियर. current given. This one current is flowing in our running in our machine, that is for 15 minutes, for 10 minutes, sorry. Okay, time is given our 10 minutes. So first we have to convert this one in SI unit. Minute is not SI unit of our time. Then we have to convert into our time only. So 10 minutes we can convert into second. Then within 1 minute, 60 seconds. Then within 10 minutes, then it will be our 10 into 60. Then it will be our 1600 second time. Time is our 1600. Okay. So charge, how many charges should be passed there? Now current came, time came, given in our question, then current how we can find? As we know the definition of the, according to definition of current, so I we can write their flow of charge per unit time is known as the electric current. So current we have, charge we have to find out, charge equal to your I into T. Okay, first beta we have to check in our question that those terms are given not in SI unit, then first we have to convert into SI unit, then we can solve it. Okay, so here I is equal to, current is given 15 ampere and time is given in our question 10 minutes, then we have to convert it into our SI unit, that will become your 600 second. So it will be equal to your 600 second. Then you can write here what? Okay, then here 0, 0, then 0, 9. Okay, this one answer will be there, then it will become in coulomb only beta. This one SI unit of the charge that we have converted into an SI unit current and your time. So coulomb charge also will come in our SI unit only, and SI unit of the charge is coulomb. So here right option, you can check your options. Now right option will be equal to your 9000 coulomb. Okay, so next question we are checking there beta, which of the following forces is or are the fundamental in our nature? Okay, different forces are given in our question. Then this also your previous year of the NDA. Then here question you have to check beta. Then which of the, read your question, then here we have to check out, then how many forces are our fundamental forces? Fundamental means basic forces. Okay, another forces will come out from these forces only, that's why these we are calling it fundamental forces. So fundamental beta, gravitation force, this also a gravitation force. Next will be electromagnetic force, this also our fundamental force. Okay, gravitation force, that is a force which is acting between the two heavily masses body. If two bodies are having masses, then we can call it their force is acting between them, that is our gravitation force. Next one, electromagnetic forces. Electromagnetic forces, that forces which is act between our charged particle and due to the magnets, then we will call it electromagnetic forces. Okay, strong and weak force. Strong force means what? That is a force which is acting inside the nucleus of the atoms. Okay, that is a strong force is acting between the nucleon. Okay, that is the strongest force in our nature. Clear? And weak force, this are weak force, but as compared to the gravitation force, it is a more. Okay, so these all forces are our fundamental forces. Another forces like this one also we are reading, restoring force, spring force, that is friction force. Okay, these all forces also come out from these forces only, category of these forces, but fundamental basic forces in our nature, these four only. Okay, so according to mass, if we are distributing beta, according to that force strength, if we are dividing these forces, that we can say gravitation force, next we can write their weak force, then your electrostatic force, then it will be strong force. Okay, these we are dividing according to strength. If strength of the gravitation force is 1, then strength of the weak force will be equal to 10 raised to power 25 times of our gravitation force. Okay, if this one will be 1, then its strength will be more than 10 raised to power 32 as compared to this one. Okay, strong force if we are taking, then it also will be beta maximum strength of this force as compared to the another forces. So this one is the ratio of these fundamental forces according to this one. As we are comparing this one, as we are taking the gravitation force is 1, then these another forces will be times of the gravitation force like this one. Okay, so strongest force will be this one. So we can say beta all these are our fundamental forces. So which one is the right option? 1, 2, 3, 1 and 2, and D is given beta 1, 2 and 3. All are the option for our fundamental forces. Okay, so here I told you beta strength also, how much strength of these forces, what is the relation between their forces according to strength. Next question we will see, what is the total resistance in the following circuit? Okay, options are R by 2, 3R, 3R by 2, 2R by 2. This one your previous year, that is a 2023 NDA. So here diagram is given, this one circuit diagram. According to this one circuit diagram, you have to find out equivalent resistance. So equivalent resistance, how we can find? How we can find equivalent resistance? We have to check which are given in series, which are given in parallel. Okay, so we will take a one end, start from this one end, then this one is divided into two parts. As your connection is dividing it two or more part, that means your parallel connection starting there. Okay, so for this one and this one, then we can write their equivalent in parallel. R equivalent in parallel, we can write there 1 by R plus 1 by R. Okay, this one parallel connection, as we are connecting this one with a one point, then again it will be starting your series connection. So till here both resistance we will take in parallel only. So in parallel we can write there 1 by R plus 1 by R, equivalent resistance R only. So here we can write there, we will solve 2 by R. Okay, so after that R equivalent will become there in parallel, R by 2. This one in parallel. Okay, किसके लिए? Parallel के लिए. After that one more resistance is given, then this one resistance will be series with this R equivalent resistance of the parallel. Okay, किसके लिए था? Parallel के लिए. Clear? So R equivalent, this one we will add here. R equivalent, you are come there R by 2, equivalent resistance of these both plus your R. In series, how we can write there? R1 plus R2 plus R3 like this one way. So take this LCM, then here will be your R and it will be your 2R. Okay, so here we can write there 3R by 2. This one your R equivalent. Clear? So our answer will become beta 3 by 2R. Check your option is there or not. R by 2, 3R, and there 3R by 2 and 2R by 3. So coming your 3R by, so your C option will be right option of this one. How we can connect this one? Complete circuit in series and parallel. Okay, first we will check our complete connection series and parallel. In series we can write there R1 plus R2 like this one, and in parallel we can write there 1 by R1 plus 1 by R2 like this one. So in an electric circuit, a wire of the resistance 10 ohm is used. इलेक्ट्रिक सर्किट के अंदर कह रहा है कि एक रेजिस्टेंस, एक वायर है 10 ओम का यूज किया गया. दिस वायर स्ट्रेंथ इट्स लेंथ डबल ऑफ इट्स ओरिजिनल लेंथ, देन व्हाट इज द वैल्यू ऑफ द करंट? क्लियर? ये कह रहा है करंट वायर है 10 ओम, एक वायर है जिसका रेजिस्टेंस क्या गिवन आपको? 10 ओम रेजिस्टेंस गिवन है. क्लियर? इफ दिस वायर इज stretched to the length initially, if initial length we are taking beta L only, initial length we have taken L, then we can write their area A. Yes or no? So in form of this one we can write there R equal to rho L by A. तो हमें क्या निकालना? करंट निकालना कि अगर लेंथ को डबल कर दिया जाए डबल लेंथ पे तो करंट कितना हो जाएगा. क्लियर? अगर हम इनिशियली उसकी लेंथ क्या लेके चल रहे हैं? L लेके चल रहे हैं, एरिया A लेके चल रहे हैं. सो R we can write there rho L by A. R क्या है? Rho L by A. So here R we can write there 10 ohm, then length is this one, then resistance is this one. So same here, if your resistance will be there, resistance first we have to find out if length will be double, how much change in the resistance, because current find करने के लिए हमें क्या चाहिए? Voltage and V equal to IR. Okay, so first we should know that how much change in the resistance as we are increasing the length of our wire. So initially L length is area, then if length L dash become the double of the previous one length, then if wire is this one, अगर इस लेंथ को खींच के बड़ा कर दिया जाए, डबल कर दिया जाए, तो एरिया में एक चेंज आएगा कि नहीं आएगा? इट विल बी चेंज ना. ओके, सो दिस वन विल बी चेंज. A dash we can write there how much. Okay, this one we will check here. Then here R dash we can write there, R dash equal to rho L dash by A dash. अब हमें पता रेजिस्टिविटी क्या रहती है, सेम मटेरियल रेजिस्टिविटी विल रिमेन सेम ओनली, यस ना. तो हमें ए डैश निकालना है. ए डैश कैसे निकालते हैं? वॉल्यूम विल बी रिमेन सेम इन बोथ केस. सो ए एल इक्वल टू ए डैश एल डैश. ए डैश वी कैन राइट देयर ए बाई एल एंड डाउन साइड डबल ऑफ द इनिशियल, देन हियर वी कैन राइट देयर ए बाई 2. क्लियर? सो ए डैश हमारे पास क्या आ गया? ए बाई 2, यस ना. Volume will remain same of the material as we are changing its length. That's why volume we can write their area into length. तो हमें change in area निकल जाएगा बेटा. कितना change आ रहा है एरिया में? That is a half of the initial area. जो इस टाइम पे जो एरिया था उसका क्या हो जाएगा? हाफ हो जाएगा. So here we can put value of a dash. A dash की वैल्यू हमारे पास क्या निकल के आ गई? a by 2. क्लियर? और l dash क्या हमारे पास? l dash की भी वैल्यू पुट कर सकते हैं. L dash की वैल्यू भी आ गई हमारे पास. L dash equal to your 12. Clear? So rho equal to your that it will be your 4L by A. This one came na, 2 we will take upper side. Then R dash will be 4 rho L by A. This is the relation between your previous one resistance and new resistance. Rho L by A. Rho L by A को हम क्या लिख सकते हैं? R लिख सकते हैं, previous resistance. Okay, so here R equal to our came, R dash equal to our came 4 into your R. तो हमारे पास R dash क्या आ जाएगा? 4. Previous year given your 10, then it will be your 40 R dash. Came R dash. So हमें क्या निकालना था? करंट निकालना था. Clear? In the circuit, then resistance is 10 ohm is this one wire, then stress this one wire को change किया गया, voltage क्या रहेगी? remain same रहेगी. क्लियर? अगर इसको हम चेंज कर रहे, रेजिस्टेंस हमारा 40 ओम हो रहा है, तो करंट में हमारा इनिशियली करंट क्या रहेगा? I इक्वल टू यार V by R. ओके, वोल्टेज विल रिमेन सेम एंड रेजिस्टेंस इज आवर 10 ओम, देन योर करंट विल बी दिस वन V by 4. सेम I dash if we are using, then your voltage will remain same, resistance will be equal to your 40 ohm. Yes na? R equal to 40 ohm. So here we can write it here V equal to your 4 into your 10 ampere. Yes or no? Here 10 ohm. V into, we are dividing into 4 into 10. Okay, so this one our your previous one current, previous year current. So here we can write there I dash equal to our I by 4. तो हमें क्या निकालना था? ये कह रहा था कि कितना टाइम्स करंट इन द सर्किट बिकम्स, अगर लेंथ को डबल कर दिया जाए तो करंट कितना टाइम्स हो जाएगा? सो ऑप्शंस आर योर हाफ ऑफ द ओरिजिनल. See there, half becomes no. This one wrote option. Double of its original length. No, your new current becomes your 1/4 of the previous current. So next C option will be right, beta. That is 1/4 of the original value. Original value of the current is I, and new one current after the changing length, that is I dash. So our came I dash equal to your 4 times of the I. So which one will be right option? C will be right option, our 1/4 of its original length. I hope you understood beta. First we have to check beta, क्वेश्चन में कह रहा है कि 10 ओम का एक रेजिस्टेंस, फॉर एग्जांपल दिस रेजिस्टेंस 10 ओम का रेजिस्टेंस गिवन है, तो कह रहा है कि अगर वायर की लेंथ को डबल कर दिया जाए, इस वायर की लेंथ जिसका 10 ओम रेजिस्टेंस है, इस वायर को क्या कर दिया जाए? डबल कर दिया जाए, बढ़ा दिया जाए, तो इसकी करंट की वैल्यू में क्या कोई चेंज आएगा कि नहीं आएगा? करंट किस पे डिपेंड करता है? करंट इक्वल टू V by R. वोल्टेज रिमेन सेम, इस वायर पे वही वोल्टेज अटैच कर रखी है, बट अगर करंट की लेंथ में चेंज करते हैं तो कीप इन माइंड बेटा, अगर मटेरियल सेम रहता है तो रेजिस्टिविटी तो वही रहती है, बट रेजिस्टेंस क्या होता है? चेंज करता है एज वी आर चेंजिंग द लेंथ एंड एरिया ऑफ आवर वायर. ओके, सो ये कह रहा है कि डबल अगर कर दिया जाए तो करंट में कितना चेंज आएगा? उससे पहले हमें चेंज निकालना पड़ेगा, रेजिस्टेंस में कितना चेंज आएगा? If we can find change in resistance, then put here, then easily we can find the change in the current की current में कितना change आ रहा है. So using this one, your relation between resistance and resistivity for your length and area, then we will use there R equal to rho L by A. Okay, so here by using better direct you can use this one formula also, R dash equal to your N square R. Direct you can use this one formula, new resistance equal to square of the N into your previous one resistance. N will be your change in the length, how many times we are changing the length of the resistance. Then using this one direct you can use R dash by using formula, then put here, then current will be came out. So your current will be 1/4 times of the previous current. Now next question. An electric bulb is rated 220 volt and 80 volt. Then when it is operated on a 110 volt, then what is the power in this one? Clear? तो ये कह रहे हैं कि एक बल्ब है जिसके क्या है 220 वोल्ट सप्लाई अगर हम उसको प्रोवाइड करवा रहे हैं, then 80 वोल्ट is the power of the bulb. Then what is it is operated on a 110. If we are providing the supply 110 volt, then what is the change in the power? Power के अंदर क्या change आएगा? Clear? So how we can find this one? Your initially power equal to given your 80 volt, then your 220 volt, voltage is given your 220 volt, V1 we can write there. When it is operated on this one, then here we can write there V2 equal to 110 volt, then power what will be there? P2 we have to find out. Clear? If voltage is given and power is given, then we should know about the relation between this. Also previous year question beta of 2023. So here first we should know about their power and voltage relation. There is a different three relation for the power. P equal to I square R. Okay, P equal to your V square by R. Okay, P equal to VI. So here we will use their P equal to V square by R because voltage is given and your resistance bulb is remain here change. Okay, so we have to find out by using this one P equal to V square by R. So power is in first case your power given, voltage given, can we find the resistance? जितना रेजिस्टेंस उस बल्ब का यहाँ रहेगा इस केस में भी यहाँ रहेगा, क्योंकि सिर्फ क्या कर रखा है पावर की सप्लाई चेंज कर रखी. फर्स्ट इनिशियली वी आर कनेक्टिंग दिस इलेक्ट्रिक बल्ब विद दिस सप्लाई 220 वोल्ट सप्लाई. उसके बाद कह रहा है इसी बल्ब को उठा के क्या है 110 वोल्ट की सप्लाई के साथ कनेक्ट कर रहे हैं. सो हाउ मच चेंज इन द पावर ऑफ द बल्ब, पावर में कितना चेंज आएगा. सो फर्स्ट वी शुड नो अबाउट देयर P इक्वल टू योर V स्क्वायर बाय R. So here we can write there R by using this one formula, then resistance we can find. That resistance will be equal to P by V square. P by V square. So here P will be equal to your 80 volt and V will be your 220 into your 220. Okay, ये क्या आ जाएगा हमारे पास रेजिस्टेंस आ जाएगा. क्लियर? यही सेम रेजिस्टेंस इस केस में रहेगा कि नहीं रहेगा? बल्ब तो हमारा सेम ही है ना. वी आर नॉट चेंजिंग द इलेक्ट्रिक बल्ब, यानी कि एक बार उस रेजिस्टेंस का बल्ब यूज करें, एक बार उसका, सिर्फ हमने चेंज की हमारी सप्लाई कि हम एक बार उसको 220 वोल्ट की सप्लाई प्रोवाइड कर रहे हैं, एक बार उसको 110 की प्रोवाइड करवा रहे हैं. सो हियर सेम सप्लाई, डिफरेंट सप्लाई वी आर प्रोवाइडिंग टू द सेम बल्ब. So here resistance will be remain same in both cases. So resistance is given here, resistance we will keep, then power, second power we have to find out change in power. So using this one we can write there P2 equal to our V square. V square is equal to 110 into our 110. Okay, and divide by equal to your, so equal to your P equal to V square by R. V square equal to this one came, yes or no, and divide by your R. R is came your 80 into your 220 into your 220. Okay, so this one power will come when we will solve it, then your answer will be come out. Okay, so you can solve it beta, solve this one calculation, check your answer, then which one will be right option, comment your answer in this question. Now next question, which of the following statement correctly explain the existence of the positive forces between the electric charges? Clear? क्वेश्चन के अंदर कह रहा है कि हमारा जो फोर्स है वो पॉजिटिव, एक्सप्लेन द एग्जिस्टेंस, जो हमारा फोर्स रहेगा दो चार्ज के बीच में, दैट इज अ फोर्स बिटवीन टू चार्जेस, इन विच केस इट विल बी रिमेन पॉजिटिव. ओके, because there is a force will be beta different, two types are there, positive or negative. If we are taking positive positive, negative negative, then they will be repel with each other, and positive negative, negative positive if we are taking, then they will be attract with each other. Okay, but as we will take positive negative charges, then force between them will be equal to what? Negative. Okay, positive negative. Okay, they will be attract with each other, but force will be there negative. If we are taking positive positive, negative negative, then they will be repel with each other, but force should be there positive. Okay, so here I hope you understood beta. If there is a same charges we are taking, same charges, then force will be repulsive. फोर्स क्या रहेगा? रिपल्सिव रहेगा, बट कैसा रहेगा? पॉजिटिव, बट पॉजिटिव फोर्स रहेगा, पॉजिटिव फोर्स. ओके, नेक्स्ट विल बी इन विच स्टेटमेंट, दैट इज योर options are both are positive, both are negative, both are opposite charges. Opposite charges should be there. Opposite means one will be positive, second will be negative, one will be positive, second will be negative, like this one. And opposite also will be there. Then in that case force will be equal to our what? Attractive. Okay, that will be attractive force. Force will be attractive, but it will be negative force. It will be negative force. Okay, because positive negative, negative positive, it will be your negative. So check your options, both are positive, both are negative, both are same charges are there in this in both option. For same charges, then force will be positive. So third one option here, both should be opposite with each other. So in these two cases force will be positive, but in this case force will be negative. So check your options, one only, two only, 1 and 2, and D 1, 2, 3. So which one is the right option? First and second. So C will be our right option. In that case here force will be your positive, but it will be repulsive. Okay. Next question beta, question number 9. So electric wire of resistance is a 5 ohm, is a cut in equal the 5 equal wires, then these wires are connected in parallel. Then what are the equivalent resistance of this combination? So here 50 resistance a wire is there, that we are cutting 50 ohm. Total resistance of this wire is given here 50 ohm. Here cut into 5 equal wires. So this one resistance will be divided into 5 equal part. R1 equal to your R2, sorry, equal to R3 equal to your R4 equal to your R5. One wire is there whose resistance is your 50 ohm divided into 5 equal portion. So here we can write there R1, R2, R3, R4, R5, all resistance will be in equal amount. So each resistance will be equal to our 10 ohm. Yes or no? 10 into 5, then it will be 50. Clear? So here, then this one, what is the equivalent resistance? We have to find out equivalent resistance. Then we can write there in parallel. In parallel we are connecting, so in parallel equivalent resistance, how we can write there? 1 by 10 plus 1 by 10 plus 1 by 10, 1 by 10 plus 1 by 10. Because in parallel we will take 1 by R1 plus 1 by R2, like this one, series up to NF. So here take LCM of this one. Then after that we can write there 5. Then it will be give us your R equivalent. Solve it, then it will be equal to beta 2. Keep in mind beta, always write SI unit of each quantity. So here A will be right option of this question. Okay, equivalent resistance will become our 2. Now last one, electric field lines from isolated positive charge conducting the sphere are. Okay, electric field lines की property you have to tell there if charge is positively charged. Okay, कोई charge है जिसका क्या nature है? positive nature है, that is conducting sphere. एक conducting sphere के ऊपर हमने positively charge distribute कर रखा है. Then how their electric field lines will be generated from this sphere? So options are tangential from the surface of the conducting, at the right triangle to the conducting surface and toward the center of the sphere, and next will be at the angle of this one conducting sphere and the right triangle of the conducting surface and outward from the center of the sphere. Okay, keep in mind beta, if any positive charge will be there na, then electric field lines will be like this one, like this one way. Okay, they will be come out from any surface or any point charge, then always will be perpendicular to that surface, and they will be come outward direction from the positive charge. If negative charge will be there, negatively charged will be there, then they will be perpendicular on the surface, but direction should be inward. Direction कैसी रहेगी? Inward रहेगी. So you can check your option which one will be right, which is not tangential surface. Okay, right triangle, right triangle. Yes, this one is right. But see here, direction toward the center, and here outward from the center. So due to positive outward, due to negative will be inward. So right option will be our D option. Okay. So I hope you understood better. Today we'll discuss some questions related to our previous year question of the NDA. Thank you for watching today our video.